Okay, so here we have it. We have a vector. It has an initial point, we'll call it P, and a terminal point, we'll call it Q. A vector has direction, meaning that it takes off at a certain angle, theta, and it has what we call a beginning point and an ending point. The distance of the vector is called its magnitude, the length of the vector. And in application, the vectors generally refer to as symbols of force. So for example, if I force my fist to Terry's shoulder right now, the magnitude was not that great, right? But if I increase the magnitude, then I would probably break my hand, right? Because, you know, she's steel, right? Yeah, okay. So we won't try that. I don't want to hurt my hand, so we'll just pretend, right? But so there's force that's delivered, okay? Kind of like if I, you know, if I push against this wall, is the wall moving? No, but it's delivering. I mean, if I pushed hard enough, would it move? Okay, and then the wall would move. Parts of the wall would actually move to the other side. Okay. All right. Yeah, exactly. The wall is actually pushing back with an equal and opposite force right now. Yep. So, but the direction right now will be horizontal. As I walk, if I stomp my foot on the ground, that's a vertical force. So let's look at just kind of some of the raw examples of vectors. If this is vector v, for example, and I want to draw negative v, I have the same initial point, but I head off in the opposite direction. Two v would be a vector in the same direction, but twice the length. One half v is a vector in just half the distance, half the length. Negative 4v, what would that look like? Yep, 4 times the distance in the opposite direction. Okay. So those are examples of drawing vectors that relate to kind of a starting one. Okay. So what we're going to do here is we're going to sketch examples of these vectors given a and b. We're going to actually show you how to graphically do a vector addition and vector subtraction, which would be pretty cool. So I'm going to draw negative a here. I'm going to draw negative b. And finally, I'll draw vector b. So probably not the best, but as good of a representation as I can do right now. Okay. So you see I drew negative a, which is just vector a, same initial point, but in the opposite direction. Vector b, same initial point, opposite direction. What I want to do now is I want to do vector a plus vector b. So the question is, if I took vector a and added onto it vector b, what would be the result? And the result is I could take this vector b and I can place it right on the end of vector a. So I have vector a, and then from there I operate vector b, and I reach a new terminal point. And that represents vector a plus b. And that represents vector a plus b. If I did b plus a, would it be the same or would it be different? How would it be different? We have a couple conclusions here. Some say it would be the same, some say it would be different. Tell me. Yeah, if you drag vector a right over to b, you're going to end up in the same position. So b plus a and a plus b are commutative, and so they end up in the same situation. How would I do a minus b? And then attach on a negative b. Looks like I left that a little bit short, but as good as we can do right now, or as good as I can do. So that would represent then a minus b. And how about b minus a? I take vector b, and then I operate on a negative a. I end up with this position right here. B minus a. What do you think? Can you accomplish those tasks in your assignment today if you were asked? Very good. So now let us go to horizontal component form of a, or horizontal and vertical component form of a vector. We don't often write vectors in this way, say with an initial point of P being AB and a terminal point of Q being CD. Rather, we take the beginning point and the ending point and we kind of work them together. And we come up with a coordinate that has a horizontal component and a vertical component. And instead of using parentheses, we use these kind of, I don't know, alligator symbols. I don't know. What do you want? Pac-Man symbols, whatever. Okay. And so the horizontal component is your terminal point for x minus your initial point for x. So it's c minus a. And your vertical would be d minus b. And that gives you a new form that we call a component form of a vector. It's quite simple. Initial point Q, terminal point, or I'm sorry, initial point P, terminal point Q. I do 7 minus 3 to get 4, and I do 5 minus 4 to get 1. So I have 4, 1 as my terminal point. And my initial point now is 0, 0. Watch, I'll show you how this works. I'll map out 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 3, 4, 7, 5. That's my vector. What we did is we took it and put it in component form. Watch what happens if I drag this down to 0, 0. What is the coordinate of its terminal point now? 4, 1. So when you put it in component form, it's simply translated so that it begins at 0, 0. Often in word problems, it doesn't matter where we start, and we like to start at 0, 0. Yep. So let's quick find the component form of this vector. Again, it's always Q minus P. So what do I get? Seven, negative 3. So now we come to something we call magnitude of a vector. And we're going to solve for direction as well. Magnitude of the vector is the distance it is from the origin. The distance from the origin. Now, if you think about this, the distance from the origin, that's another way of saying the absolute value, correct? Have we seen that before in the last section? Yeah, so the absolute value of the vector is just like when we talk about the absolute value of complex numbers. We get the square root of a squared plus b squared. Given that vector v is ab. Anybody want to take a guess as to how I come up with the direction? You know it. Sitting right in that brain of yours. Has to do with trigonometry. Tangent of theta is b over a. Yep. We just solved that, and that gives us theta. So again, this is stuff I would put in your notes if I were you, as you make your note sheet. So we start with example 4. Find the magnitude of each vector. Okay. 5, negative 2. Magnitude is going to be the square root of a squared plus b squared, which would be 25 plus 4. This one, square root of and this one. We'll practice where we find the direction in a little while. Right now we know that tangent theta is b over a, and we'll solve for that later. Sum and difference of vectors. Suppose that vector v is equal to ab. Whoop. Yeah, ab. And vector u is equal to cd. Then v plus u is equal to a plus c and b plus d. Simply add the horizontal components and add the vertical components, and that will give you the new form of the vector. Okay, so given A is this component vector and B is this component vector, we want to find the following then using that property. We want to find 3A. You say, well, we haven't done multiplication yet. Well, this is just A plus A plus A. So A plus A plus A would give you 3, 9. So you can see you can simply multiply the 3 through and you're good. 4B would be 8, negative 8. So how would I do A plus 2B? 1, 3 plus what? 4, negative 4. And what do we get? 5, negative 1. I do 2a minus 5b. So let's see, 2a would be 2, 6 minus, and if I do 5b, 10, negative 10. Negative 8, 16. There we have it. Easy enough so far? Now your book says that it wants to teach you how to put vectors not just in component form, but in terms of I and j. I don't understand why they do this. My only thought process could be that back when they had typewriters, they didn't have these symbols. And so, you know, what they decided to do instead is attach letters so that you can, you know, readily interpret it. I don't know any other reason. You're not going to have to do this on the test, but your book might give you a problem where instead of writing it in this form, we'll say that vector u is equal to, we'll call it mn, okay? We'll call it mn is our vector. Then you can represent it like this instead, mi plus nj. That's the same thing. You won't be asked to do it on a test. You just have to understand that if they ask for it in that form, that you can interpret it. So for example, if they gave you 3, 6, that would be 3i plus 6j. It just, I know. I don't have a good answer for you. So. Vectors have what we call horizontal and vertical components. So I'm just going to use some scratch area here. You don't have to write this down. You can just follow along. If I have a vector that has a terminal point of AB, okay, so it's in component form, That means that this length here would be A, and this length here would be B. This is the magnitude of the vector, and this is theta. So what I would like to do is come up with a new way of expressing A and B based off of my knowledge of the absolute value of V and theta. So in terms of opposite, adjacent, and hypotenuse, what is A in this triangle? Opposite, adjacent, or hypotenuse? Adjacent, which of the three trig functions does that make you think of? Cosine. So we could set this up. Cosine of theta is equal to A divided by what? Yep, the magnitude of the vector. And we could solve for A then by saying that the magnitude of the vector times cosine of theta is equal to A. Similarly, if you want to find, if you want to think about B, B is the opposite. So you think of what trig function? Sine of theta is equal to B divided by the magnitude of the vector. So the magnitude of the vector times sine of theta is equal to B. Or in other words, you could replace A with this, and you could replace B with that. So we get the vector magnitude of V times the cosine of theta, and the magnitude of V times the sine of theta. So this is the horizontal component, and that's the vertical component. So we'll write that down back in our notes. We have horizontal and vertical components. The horizontal component is the magnitude of V times the cosine of theta, and the vertical component is the magnitude of V times the sine of theta. Pretty straightforward, right? Yep. So what we know here is that this vector has it has an angle of 30 degrees, direction of 30, and it has a magnitude of 3, okay? So this is where it ends up right there, magnitude of 3, angle of 30 degrees. Well, what it wants us to find out is it wants us to find out both B and A. It just wants us to put it in component form. Then once it's in component form, we will go ahead and put it into IJ form. Okay, so how do I find A? Three times the cosine of 30 degrees. Do you know what the cosine of 30 degrees is? So we get 3 roots of 3 over 2. Three times the sine of 30 degrees. 3 times 1/2, or 3/2. So that's the component form of the vector. If you wanted to write it in terms of I and j, you would have 3 roots of 3 over 2I plus 3 over 2j. Both are the same. I will never ask for ij on the test. I'm only showing you because your book uses that terminology. I don't know why. Again, I don't think they had like this symbol on the typewriter or something. I don't know. That's all I can think of. And that just came to me this morning, and I thought it was pretty intelligent for thinking of that. So I don't know if you guys have another thought, but I'm kind of, yeah. Does that sound reasonable? You don't know what a typewriter is? You are a millennial and don't know what you've never seen a typewriter. Okay, now she's lying. Don't make up lies. All right. So what I would like you to do is please do this one on your own. Okay, please do the next one on your own. Come up with component form, and after you come up with component form, put it in IJ form. Okay, any questions on that result? Tristan, do you know what you're doing? Does that make you happy? Good. What if I said that I will not confuse you the rest of today? Almost. Do examples 7 and 8. We'll leave the plane example for later. Find the magnitude and the direction of the vector. Remember, the magnitude of a vector is equal to the square root of a squared plus b squared. But now we also want to find theta. We know the tangent of theta is equal to b divided by a. So the magnitude of v is equal to the square root of 1 plus 4, which is the root of 5. Very good. I know that the tangent of theta is equal to what? Negative 2. Tangent is negative. In which quadrant is tangent negative? Second and fourth. If you were to plot this vector, would it be in the second quadrant or the fourth quadrant? It would be in the second quadrant. So we're going to look in the second quadrant. And I told you that at 7.6, you were in radians. And 7.7 through 7.8, you are in degrees. Anything with vectors, we will solve for in degrees. So I'll go ahead and take out my handy-dandy calculator. And so I second tangent inverse 2. And I get 63.43. I'm going to subtract that off of 180. And I get theta is 116.57 degrees. So magnitude of the vector is the root of 5, and the angle is 116.57 degrees. Any questions on that example? We've done that before, right? We're now just putting in terms of vectors as opposed to complex numbers. You will, not everything with vectors relates exactly to complex numbers. I will show you on Thursday, assuming that we're able to have that class at that time. Via video, you'll see how we can come up with some other things. For example, we haven't learned how to multiply two vectors together. And we haven't learned how to find the angle between two vectors. Some really good stuff there. Okay, this one, we have the magnitude of the vector is equal to the square root of, what if I square a? 1/3. And what if you square negative 1? 1. So what I end up with is, okay, so the root of 4/3, I can take the square of the top to get 2 over the root of 3, which is 2 roots of 3 over 3. So that's my magnitude for the vector. And then to find the angle, you subtangent of theta is equal to negative 1 over the root of 3 over 3. And some people try to simplify it at that point. You maybe don't want to simplify it there. Maybe you just want to plug it into your calculator at that time. But be very careful when you do. We have negative 1, and then you're going to divide by a quantity because it's a fraction. So I have to insert a parenthesis. And then I press the root of 3. What is the next button I press? Parenthesis, because you don't want to take the root of 3 divided by 3. You want to take the square root of 3, find that result, and then divide it by 3. So divide by 3. And now we will end that parenthesis for the denominator, and then we'll end the parenthesis for tangent inverse. And we do get, I put in negative 1, so we got negative 60. Had you put in the same entry, you just take off the negative 1, which I should have done because that's what I usually teach you to do. Delete, enter, you get 60 degrees. You know you are in which quadrant? Fourth quadrant, because you have a positive horizontal component and a negative vertical component. So I'll place you at 60 degrees. Subtract that off from 360, and you get Theta is 300 degrees. Good work. So, our last example, we try a basic word problem. A man pushes a lawnmower with a force of 24 pounds. Handle forms a 40-degree angle with the ground. Find the horizontal and the vertical components of the force. Oh, he does not have a body. True, the branch. All sorts of leaves in the trees. Some bark. Mowing the lawn, he's sad. Didn't really change the oil on the lawnmower, so it's smoking. Poor guy. All right. So, 24 pounds of force. And you can see that it forms a 40-degree angle with the ground. $40-degree angle with the ground. So I need to come up with a horizontal component and a vertical component. How do you find A? (24) times the cosine of 40. And B would be 24 times the sine of 40. So although he's exerting 24 pounds of force, that's not how many pounds of force he's exerting horizontally or vertically. That's at an angle. So let's figure out how many pounds of force are actually in each direction. And so we'll just take out our calculator because there's no nice value for sine of 40 or cosine of 40. Well, there probably is, but we'd have to use a lot of sum and difference and half angle stuff, and that would be quite a bit of work. So we get 18.38 pounds of force are exerted horizontally, and then 24 sine of 40, and that's what's exerted vertically, 15.43. And that's that. So in other words, suppose that the lawnmower weighs 100 pounds, then the ground feels like the lawnmower weighs 115.43 pounds as you're pushing it. Okay, because that's the vertical force. Okay. Let's say that the tree weighs 17 pounds. Then you'd be able to knock it over as you're pushing the lawnmower, right? Maybe it's a dead tree. Just a sapling. Okay, I have an assignment for you. 7.7, page 599, numbers 1 through 6, 17, 18, 23, 27 through 39. The odd. Will you have an assignment tomorrow? No. Will you have an assignment on Wednesday? No. You will only have one more assignment between now and next week, Tuesday.